And in continuing with the Monty Python references, and now for something completely different. So I want to start with admission that I feel a bit of a fraud giving a paper on scientific techniques in archaeology, because I'm not a scientist, and I won't even pretend that I understand the intricate principles behind any of the methods that I'll be talking about today. But what I do understand is the incredible value that these provide in addressing a number of new and exciting research aims and questions in areas such as craftworking technologies, object recycling, agricultural strategies, population movement, diet, health and relatedness, and a whole host of other different themes. So what I'm going to do over the next 15 minutes is really just provide a whistle-stop account of some of the techniques that we've been using recently in developer-funded archaeology, and some of the research questions that these are starting to address. Now, of course, there are many other different techniques and many other different methods that are used, both within UK commercial archaeology and within academia and within other organisations, both in UK and abroad. But I thought within 15 minutes, that was probably a little too ambitious to go into. So I'll stick with a selection of the UK techniques. Now, first thing to mention is that although the techniques that I'll be sort of describing can be used at archaeological sites of all different scales, it's really with large infrastructure projects that we get probably the best opportunities to utilize some of these techniques at great scale. And it's also in these sort of infrastructure types that we get opportunity to trial innovations that is not always possible with smaller, tighter margin, smaller archaeological projects. And so because we've got a large number of these projects that have been undertaken in recent years, and certainly there's going to be looking at over the next 4 or 5 years, 10 years, including a rather large rail scheme going through the central part of England, which you may have heard of. There's going to be an amazing amount of opportunity to utilize these and develop new techniques that will really help to address some of the research questions and a whole host of new other research questions that I've just mentioned. So it's a really exciting time. The site you can see there on the screen here, that is part of the A14 project, a massive, it's part of a £1.5 billion road improvement scheme between Cambridge and Huntingdon. And a tremendous amount of work has been done by Mola Headland Infrastructure over the last 8 years. We're just coming to the end of that project now. And many of the examples for some of the techniques that I'll be sort of mentioning today come from this project, although that's just because it was most handy to me and most fresh in my mind. There's obviously lots of other projects which utilize these techniques. So I'm going to start with something which is obviously very well established. Radiocarbon dating has been used for a long period of time, although it has to be said it's only relatively recently that it's become a really common part of scope for virtually all archaeological developer-led projects in the UK. Further than that, we're also starting to take larger numbers of radiocarbon dates. Obviously, on big projects like the A14, we had over 450 dates from that project, but even relatively small sites, but one of the ones we looked at, we've done recently at Lower Callerton near Newcastle, over 75 dates from a single site there. So large numbers just from one site. And we're just, as a medieval site, we're just tackling in Edinburgh. We've got over 100 dates from that relatively small site, albeit with complex urban stratigraphy. However, although it is, as I said, it's been used as a sort of a regular part of commercial archaeology for some time, there is still a reluctance to date sites from certain periods where there's perceived to be a greater ceramic chronology. It wasn't that long ago, very recently, that I was given curatorial guidance that we shouldn't date some of the skeletons from a Roman site because we knew they were late Roman. And of course, they turned out to be early Roman. And then, of course, using radiocarbon dates on Roman sites, it not only refines the chronologies, but it's also one of our best chance of looking for the more elusive 5th century, which is obviously incredibly important research aim. So moving on, isotope analysis is also something which is now starting to become an increased part of project scope within a number of projects, although I still think there's some work to go on that, so it becomes a more regular part of a wider scope in more projects. This particularly on human remains, strontium, oxygen, and lead for mobility, and carbon and nitrogen for diet. For the A14 project, we did in conjunction with the University of Durham, isotope analysis on 42 individuals from the Bronze Age to the early medieval period. Within that, we found remarkably little change actually in diet and mobility over time, with the exception of the Roman period, whereas the diet was still fairly, for most of them, fairly consistent, but there was much greater evidence for mobility. And this has a fundamental impact upon our understanding of Romano-British rural society. I know Hella and others have done lots of great work on urban populations, but this is one of the few instances where we've done quite a large number of samples in rural populations. So these are some of the fundamental research questions which we need to sort of now build on in the next stages. Now, isotope analysis also obviously done on plant and animal remains. In animal remains, looking at long-term fodder provisions and grazing patterns and migration patterns, and there have been some great studies done on long-distance droving using isotope analysis, which has come out in recent years. Now, isotope analysis is not used so much these days, or at the moment anyway, on plants, but it can provide really good indications for variations in crop management regimes. Again, we did quite a comprehensive integrated isotope analysis as part of the A14 project. The graph you can see there is the nitrogen isotopes for wheat crops from right the way through from the early Iron Age into the medieval period. And you can see the sort of double wave pattern where nitrogen being sort of used as a proxy for manuring, we get higher levels of manuring equating to agricultural intensification in the Roman period and in the medieval period, with dips either side. So again, this is really important for our understanding of agricultural strategies, which leads on to our greater understanding of social patterns as well. And the good thing about the plant isotope analysis is it's also can be used on sites which don't necessarily have a large range of really well-preserved material. We did it again on the site at Lower Callerton in Newcastle on some Neolithic samples. Preservation was generally very poor, but we had a small number of samples where we could do this work, and it proved that there was, again, manuring on early Neolithic samples, but only really, it seems to be from the wheat and not from the barley. So that was also really interesting sort of understanding of variations, quite micro variations in crop management strategies. Now, sticking with plant remains, but on a slightly more sort of granular level, we've done, or say we, it was mostly through the development of Dr. Lara Gonzalez Carataro, then at Mola, who did scanning electron microscope analysis of these cereal-based foods. These were sort of trying to discern things like bread types the dough-like products, cereal-based products, which we can understand and differentiate under the scanning electron microscope technique. So she allowed us to, her work allowed us to look at the use of these different food types over time. So, for example, we saw that there was a greater prevalence for porridge and porridge-like products in the late Bronze Age and early Iron Age. And probably the most newsworthy item that came from that is that was it was used to discover the earliest physical evidence for beer making in the UK, which you may have seen in various BBC news reports, which was dating to the Middle Iron Age. Now, of course, ancient DNA analysis is something which has really caught the imagination in recent years, largely thanks to the amazing work of the Francis Crick Institute and their groundbreaking 1,000 Genomes project, which has been revelatory so far in its outputs. This is rescue to investigate genetic sex, ancestry, and relationships between individuals. As part of the 1,000 Genomes projects, we submitted 52 burials from the A14 sites, again from Neolithic right the way through to early medieval. And lots of really, really interesting results, which I don't have a chance to go into today, but will be published very soon. But one of the outcomes of that was there was a much greater diversity in terms of the ancestry within the Roman period population than had been previously, including some very, very significant outliers from outside of, or at least on the very fringes of the empire. So again, this is particularly effective when combined, as it has been, with the isotope analysis. It gets us real insight into the actual population of societies over time and across different parts of the country. Now, of course, it's not just environmental remains and osteological remains that have scientific techniques, as we've seen earlier today. It's also, of course, with a wide variety of artifacts. Although it has to be said, from commercial experience, there is generally less science done on artifacts than there is on environmental and osteological remains. But hopefully that will change. Now, for example, in pottery, there are a range of different techniques that are currently utilized, including these ones mentioned here: radiographic, petrographic, and geochemical analysis of pottery to look at ceramic production techniques and pottery distribution networks. It was used extensively by Adam Sutton from Mola as part of the A14 project to investigate late Iron Age Aylesford Swalling pottery as part of the A14. And amongst many different results that come from that, very fascinating results that came from that, there was the revelation that there was far fewer wheel-thrown pottery tradition, far less of a wheel-thrown pottery tradition within this Aylesford Swalling wares in Cambridgeshire than there was in neighbouring Hertfordshire. So there's quite different traditions in very close proximities, and this led to much further sort of questions on various different economic and social questions which were addressed by Adam in his study. And of course, at the REMADE conference, I couldn't really come here and not mention XRF analysis of artifacts, which is becoming more common in commercial archaeology, although it's still really not used that widely. And I really hope one of the legacies of the REMADE project that is going to change that, and XRF will become a sort of a regular standard part of the analysis that we do in the commercial world. As part of the A14 project, again, we did a comprehensive study. It was part of the master's studentships that Gemma Morehouse did, working with Pete on a large number, over 450 objects, I think it was, of copper alloy objects from the A14, with lots of really interesting results that came from that. There seemed to be a very distinctive regional pattern to it. There was increased use of wider variety of alloys throughout the Roman period, and a greater incidence of recycling in the later Roman period, amongst other things. So it was really important. And also, fundamentally, it demonstrated the cost effectiveness of using PXRF to do some broad scanning of a large range of objects within a project that again, which gave good results, and really you could see the value from this. And I think it's demonstrating the value, which I think is the most important part of it. Now, PXRF can also be used in the analysis of sites. It can be used to understand how soil composition altered by human behaviour. We've been working with Hitachi on a number of sites in east of England using PXRF analysis. This, the one the graphed here, was a villa site in Norfolk, where we've done the PXRF analysis on a number of different buildings within the site. And it found a different, this is one, there is an aisled, very big, in fact, aisled barn in the south of the villa complex. And PXRF analysis there found very distinct geochemical signatures in the north compared with the south of the building. The south of the building seems to be related to animal management, where stock were being kept. So again, this is something that we're starting to use on an analytical way within not only for artifacts but for sites as well. And I know that just last week, in fact, I had a presentation from Archaeological Research Services company who are using PXRF as a prospective tool rather than an analytical tool over wide areas with really, really fascinating and interesting results. So again, there are wider applications for some of these technologies which are just sort of fairly recently starting to be explored and implemented. And I'll finish with another sort of fairly new technique that we've been using, well, the way that we've been using it. Obviously, geophysics is a very well-established technique for archaeological prospection, but we've just been trialing it in the last few years for archaeological analysis once the site has been stripped. So we're using it to identify features that weren't obviously visible either in the previous geophysics or to the naked eye. We can use it to estimate the depths of features and the relationships between them, and areas where there's cultural debris beneath colluvium and alluvium. We're also using it to identify concentrations of anthropomorphic material and burnt material within features, so we can do more targeted excavation slots within the site. And also there is one sort of one element of it which seems to suggest that we possibly could be an indication of the date of the feature as well. And we're using that, we're developing that with the University of Bradford at the moment, the use of that technique. So that's one of the things that we've been working on over the last few years. So I'll finish there with just a few concluding remarks. I've just done a very, very rapid run through sort of a wide range of both very well used and more newly developed scientific techniques that are currently used by us in commercial archaeology. As I said, there are plenty of others as well. But what I'd say is there's much greater scope, and it's really important that especially the development of new techniques and the sort of the furthering of existing techniques is done in collaboration between the commercial sector, the academic sector, and many other sectors, museums and industry. That is incredibly important, and that's why the REMADE project, I think, is really important in that regard, of bringing various disparate groups together. And I think it's a very important part of the overall project. And one thing I'd say it's really important is we shouldn't be just doing science for the sake of doing science. They've got to be related to fundamental, specific, and interesting research aims and questions. That's absolutely important. We need to know what these techniques can tell us about sites, landscapes, and the people within it. And if we do that, and we can demonstrate its value, both financial and academic value, then I think we've got a very good chance that these techniques will become a very regular part of commercial archaeology in the future. So I'll leave it there.
Thank you, Alex, for a fantastic overview. Any questions? Yeah.
The increasing numbers of scientific techniques that are being used in the commercial world. On a big project like that, can we quantify that in terms of what amount of money is put towards the scientific elements of process as opposed to any other elements of process?
I could if I had my very detailed spreadsheet in front of me. Well, I could say the post-excavation analysis project, which is over 5 years for that project, was 4.5 million. I would say probably 10% of that. That's completely off the top of my head. Was probably used directly in scientific techniques. It might be slightly more than that, but it's probably around that, I would say.
When you discuss demonstrating value, linking it to research aims, is that very different within the developer-led excavation compared to the university-led excavation? Or is there much more overlap?
I think there's definitely overlap. It is value, and we obviously are under. Everyone's under financial constraints. The larger infrastructure projects, we have there's a huge amount of money involved in it, so they still have to represent value. That's the most important thing. So I think that goes across university and commercial. It's got to be value, but we have more scope for developing these new techniques and trialing new ones, which is the main thing. So if we go down paths where it's not giving us the results that we want, that's fine. We can then go back and then try a different route. And I think these big infrastructure projects gives us that scope to do it.
We're just going to change the slide. So we've got one further question. So you mentioned the Deborah Morehouse is wonderful master's project that you developed with Headland Archaeology here at Reading. Is there increasing scope for longer term PhD sort of scale research or ongoing collaborations?
I would very much hope so. Yeah. I mean, the 4 master students that we sponsored here at Reading were all did amazing jobs. I know one did today, Katie, I think, today. Yeah. So yeah, I think that is a future, a really good model of how to develop. It has benefits for the sector. It has benefits for the student, and it has benefits for the project and the university. So it's a win-win situation, really.
Yeah, one of the other students is Katie Manley, who's now continuing in her research here at Reading. So